Welcome to A4N, the Artificial Neural Network News Network, the show about the latest development in artificial intelligence, machine learning, and data science, where we both introduce technical aspects of these advances, as well as discuss their social implications. In today's exciting episode, we'll be discussing self-driving cars, how machine learning is revolutionizing radiology through early identification of tumors, and AI venture studios with Dr. Rasmus Rothe, the founder of the world's first and most prominent AI venture studio. My name is Jon Krohn, and I'm your host for today's program. Let's get started. So, Rasmus, where are you joining us from today, and how are things going for you under the lockdown?
First of all, thanks, John, for the invite. So I'm right now in Berlin, and I'm actually at the office right now. So we've been fully remote for 2 months at Merantix, and then a few weeks ago we started to open up the office again, and right now we are on a kind of rotation. So around a third or so is at the office right now.
Wow.
So slowly getting back to normal, hopefully.
What was the extent of the lockdown out there in Berlin? It was like completely shut down at some point?
Yeah, it was completely shut down, and I mean streets were empty, all the shops, restaurants were closed, but now as of a few weeks ago, things opened up again, and I guess, numbers are not going up too crazy, so I guess this will be the new normal for a couple of months until hopefully everything is fully back to normal. So let's see. I'm also curious what's going to happen.
Nice. Well, I'm glad it sounds like infection rates there in Berlin are staying down despite the reopening. So hopefully that's a good sign for the rest of us in places like New York, where I am, where we're just finally today ending 100 days under lockdown. So in our previous episode of A4N, we mentioned you with respect to a number of items, including your racy Ph.D. research. So not something we can say about much machine learning research, but in this case, I think it does apply because in its first month alone, people from around the world visited howhot.io to pass 50 million photos into a model you designed in order to assess the subject in the photo's age, gender, and attractiveness. We're also going to discuss Merantix. In fact, this will be the focus of the episode today, and lots of news around Merantix and its related startups. So Merantix is an AI venture studio which recently received substantial funding. So we'll talk about that news as well as what AI venture studios are. So let's start off with how you and I met, and then you can lead us from there through to your PhD.
Sounds good. Yeah, we actually met back at Oxford when I guess you were doing your PhD and I was an undergrad, and we worked together at Oxford Entrepreneurs, trying to get the entrepreneurship society off the ground at Oxford. And yeah, it was super exciting. I guess not much machine learning, at least in our work at Oxford Entrepreneurs, but still, topic of entrepreneurship we were focusing on. So that was great.
Yeah, exactly. And you've been a poster child of, from that kind of starting point where being in an entrepreneurship society as an undergrad, taking what we could learn from the various workshops that we ran and, the inspirational kinds of speakers that we had, and going off and creating your own startup, I guess, during your PhD. Is that right?
Exactly.
Or just afterward?
Yeah, it was right after my PhD. So I hadn't defended my PhD at that point yet, but I was already done with all the publications I had to do. So I had a couple of months kind of preparing the next step. And during that, I actually met my co-founder. And so then we started working on Merantix for a couple of months.
That's nice. So tell us about your PhD research. I mentioned howhot.io. That's probably not the part that you want to focus on, or maybe it is. But that was, I remember, that was big news when it happened.
Yeah, for sure. So basically, after Oxford, I spent some time in the US and then moved to Zurich, to ETH Zurich, to do my PhD with Professor Luc van Gogh. And in my PhD, I actually focused on computer vision applications, various computer applications, and also using neural networks. So I was doing my PhD between 2013 and 16. So I guess it was right when the Alex Krzyzewski paper came out from ImageNet, people started to try to apply neural networks to all sorts of applications of computer vision. And so I wrote a few papers on face recognition, inferring age and other facial traits from faces. But I also worked actually on completely different things. So I worked a bit on super resolution, which is around upscaling images to higher resolution, and you're using also machine learning there to improve quality. So Yeah, a bunch of random topics. I was actually, I think, the first or one of the first people in Luke's lab also using neural networks. So before that, it was focused more
Hmm.
on classical computer vision. But
Right.
in 2013, people started to get excited about neural networks, and so I thought, okay, this is interesting. Let's try it out, and I saw it just works really well. So that's when my PhD focused on this.
Yeah, for listeners that aren't aware, it's a main focus of in my first book, Deep Learning Illustrated. Chapter 1 is all about how in 2012 these researchers at the University of Toronto in a lab led by one of the most famous deep learning researchers, we're going to talk about him again later in this episode, Jeff Hinton. Someone in Jeff Hinton's lab named Alex Krzyzewski, which Rasmus already mentioned, released this AlexNet architecture that absolutely crushed all existing benchmarks for machine vision in 2012. And then what a time for you to be doing your PhD starting 2013 to take notice, like anybody working in computer vision would had to have, and say, wow, this is something new using these neural networks, these deep learning architectures for machine vision. How exciting. And to be able to apply those to many different applications like you have, I'm super jealous that you had that timing perfect. And yeah, that was it. The Some Like It Hot paper, was that the kind of the biggest paper that came out in your PhD? I have so that's what we talked about last week. It was this Some Like It Hot visual guidance for preference prediction. But you had a bunch of papers in your PhD.
Yeah, I think it's not the papers with the most citations, but it's certainly the one which got the most media attention. So the way it happened
Right,
is
right, right.
basically that I was setting up a collaboration with a dating app I met actually at an entrepreneurship event, and we then decided to train some neural networks on that data. And basically, at the end of the project and the paper I wrote, we then said, okay, let's build a little demo website so people can also try out the algorithm and upload their own photo and get a prediction around their age and their gender and their facial attractiveness according to that data set. Then that website just went surprisingly viral. So we just thought it would attract a few geeky researchers who find the algorithm interesting. But basically, after a couple of hours, it was already quite a few users on this website. So it was a big surprise.
Yeah, if I remember correctly, you mentioned when you were visiting New York a few years ago that the website, the cost of maintaining it, all of a sudden became like substantial, right? How did you get sponsorship for it?
Yeah, so we first hosted it at the university, and then when I shared it with some friends, the server went down, and so I was like, okay, let's set it a bit up in a bit more scalable way, and so then we hosted it on AWS, and we basically had to call them every hour to get more instances and kind of increase our quotas. So that went crazy, and like we didn't know how to pay the bills, so we just kept it running, and then I guess a few days before the bill came in, we basically then had AWS kind of support us, and in return we also wrote up a case
Nice.
study about this crazy scaling experience. So I think it was good for all sides at the end.
Well, yeah, and that is to reiterate the stat that I gave at the beginning of this podcast. There were 50 million photos, 50 million queries made just in the first month, and yeah, that was exciting. I remember that was something that came across me organically. I realized it was such a big splash in our field, and I think maybe even outside of machine learning, lots of people were just throwing their photos in to see, or other people's photos in, and seeing how attractive it rated them as. And then I noticed through that, I was like, oh, I know, I recognize Rasmus's name here. So very interesting. And then at the end of your PhD, you say that you had some time at the end there. What a fortunate situation to be in, that you have some extra months after writing all of your PhD papers to figure things out. So it was in that time that you met your co-founder. Was it PhD research that led directly to your startup, or was it orthogonal?
I think it was inspired by PhD research. So, I mean, my PhD was really focused on applying machine learning or deep learning to some areas like face recognition where it wasn't really applied much before. And so I certainly realized during my PhD that in basically every single industry and like every single application where data is available, machine learning will play a very vital role. But at the same time, I saw also kind of the challenge of even if you can just build an algorithm and you know that is obviously getting easier and easier, that is still very far from actually having a real company and a real application. Just because you can build an algorithm doesn't mean you actually have the access to the data sets you need. you have embedded your algorithms into a product that serves some users. And
Mm-hmm.
so there's much more to it in building an AI first company than just building an algorithm. And so I saw quite a lot of companies which were very much focusing on the AI part only. But my big belief is like that's only like 5% basically. And so with my co-founder, then I was exploring to figure out like what is a way to basically enable all these AI first companies and make them more successful, so they can really become a successful large company. And so that's where the idea of Merantix was born, to basically build a venture studio that serves this purpose.
Nice. I didn't know that. So the point of Merantix from the beginning was to have this venture studio concept.
Yeah, it was. I mean, we didn't know the model, the venture studio model, very well. Actually, funnily, on some slides from 2016, it says venture studios as one way how we imagine to build Merantix. But it wasn't like us saying, okay, we build a venture studio. It's more like what we built, and we only really realized that last year is actually a venture studio. So it was just, in retrospect, that's, I guess, what we've been doing for the last 4 years, even though we only started calling ourselves this starting last year.
Nice. And we'll get into details of exactly what an AI venture studio is momentarily. But just before we get there, so when you started Merantix, what was the business model? Like, what were the AI applications that you had to industry?
So in the beginning, we basically, in the first 6 months when we started Merantix, we just did a lot of interviews. So we talked to around probably like 100 companies and asked them about their challenges, and also where they have data and where they see potential. And in return, we actually explained them why AI is important. I guess now it's much more all over popular media, but in 2016, many people from the management level still wouldn't know that much about AI. So it was kind of a, we tell you about AI and you tell us about your data opportunities. And so that way we actually realized that there are so many different opportunities out there, but at the same time similar
Mhm.
challenges like getting access to data, like fitting into existing workflows, that we said, okay, we built Merantix as this kind of platform that builds AI applications, ultimately as its own companies. And so we then just started to hire the first couple of people and started to work on the first applications, which then later became the first companies of Merantix, like Vara in healthcare and Siasearch in the space of automotive, for example.
Excellent. And yes, we're going to talk about those examples in detail momentarily because they are both making a splash and both are highly relevant to two emerging AI fields. So, Vara Healthcare is transforming radiology, so in medicine, and Siasearch is transforming how data are used in self driving cars. And we're going to talk about both of those concepts in detail. But tell us what else has been incubated now in this Merantix Venture Studio, and tell us also what exactly an AI venture studio is. So how is that different from an incubator, for example?
Yeah, it's a good question. So the venture studio is a sort of incubator, but like much more focused on one theme. In our case, AI, and it also tends to focus on building less companies at the same time. So you have some of these company builder models who have been building 10, 20, 30 companies at the same time. A venture studio is a much more bespoke model where it's really only about building maybe one, two, three companies per year, but with much more dedication and focus, and also much more capital ultimately behind those companies. So that is one part. I think another part which is very special about venture studio is that um, in in company builders, you tend to have a lot of like centralized services, which you provide to all your startups you incubate. And in a venture studio, you tend to not have very much centralized services. You actually try to build really independent companies, but rather through a common brand and maybe co-location and maybe some tech infrastructure and shared knowledge, you create ultimately a benefit for all your companies. So it's not like, so all the engineers, all the product teams and everything is part of the companies we incubate. It's not centralized.
Nice. That is a super cool idea, and it seems to be taking off. You guys raised 25 million euros, or about 27 million US dollars, to expand your AI venture studio in January of this year, of 2020. And you guys were the first, as far as I'm aware, you're the most prominent of this kind of concept. And so when you're coming up with these company ideas, 1 to 3 companies a year, how does that happen? Do you take applications for people's ideas, or is it more top down where you and other existing companies or executives come up with some concepts and then find a team to build that out? How do you come up with the subsidiaries of the venture studio?
Yeah, I think this is $1 million question. It's a, I think so. So the core of what we do is that we bring entrepreneur and residents on board. So we basically hire people who want to start company with us, and in the first 6 to 12 months, when they are basically still part of Merantix, we ideate and also validate a lot of potential business ideas
Mm-hmm.
with them until we then spin out an actual company where they then become the CEO or CTO or so, and which we then also fund and kind of scale to Series A and beyond.
Wow.
The ideas actually come from very different parts. So sometimes entrepreneurs and residents bring ideas, or I guess areas of their expertise with them when they come on board. So somebody might have a very big deep background in a certain industry because the person has worked there before, or was in academia, and that's in some space, and is very, I don't know, knowledgeable about certain technology. But that's only one part of the equation. I think the other part is that we also actually, yeah, maintain relationships with a lot of VCs out there, with Merantix Labs, or one of our companies, which is our solutions provider. We also run a lot of projects, consulting projects, and service projects with large and small companies. And so obviously we also learn a lot there, where opportunities may lie. So I think it's in the end a combination of Adrian, my co-founder, and me seeing a lot of stuff, all the activities within Merantix, but also what the entrepreneurs and residents ultimately care about, and that's how the ideas get formed about. So yeah, it's pretty interesting, and we definitely put more and more structure around this process. So how we evaluate an idea. There are also a lot of things we have discarded for one reason or the other. So I think also this knowledge base helps, obviously, when you look at new ideas.
Well, I love this concept, and I have no doubt that the early success you had with it, Rasmus, is going to continue. It's really inspiring. I love the way that you've set it out, and I think great things are to come. We're going to talk about Vara Healthcare and Siasearch in detail next, but are there any other firms that you want to talk about right now that are under the umbrella of the Venture Studio?
Yeah, I can't say much. We have a few companies we are right now working on, which are pretty much in stealth and like also very early. So teams are still very small. We have one space we are particularly excited about, and I guess it's also related to your background, actually, John, is the intersection of biology and machine learning.
Mm-hmm.
So that's actually one area where we're now starting a company. Biology is certainly creating more and more data, and for example with like sequencing costs going down, but also in other areas of biology. And so I think there's a lot of very interesting applications at the intersection of machine learning and biology, basically using that data and making sense of it. And that's one of the areas where we're right now starting a company. Another area is a more horizontal topic. It's focused around analyzing a lot of data that is produced in companies. So it's in the space of business intelligence and kind of automating parts of the work of a BI analyst. Still also very early. We're already working with a few customers, but I mean, still the company is just at the beginning.
Nice.
And then there are a few other areas we're looking into. We find the data privacy and models around that also is related to machine learning quite interesting. We're also looking at some things in the space of manufacturing. So yeah, pretty broad. I mean, we're completely industry agnostic and also technology agnostic. So given my background, historically we've been focusing a lot on computer vision, but now we are also gearing more towards text language data, so NLU, NLP, because obviously there has been a lot of progress in the last 1 or 2 years from the technological side, which opens up a lot of very interesting applications.
Definitely.
But then also other types of data, like biological data, which is not necessarily image or text, but kind of maybe some other structure of data. And I think those areas are also super exciting.
Brilliant. Yeah, that sounds like a great mix. The horizontal play makes a lot of sense to me. This kind of business intelligence tools, there are lots of tools that do things like this, of course, but if you can find a specific niche, find clients that are willing to pay for that specific new thing that you're developing, then this is definitely something that can be big. And of course, yeah, I'm excited about any kind of the vertical use of natural language processing, which is it's my focus today, as well as the biology stuff that used to be my focus when I was doing my PhD. So that's wonderful, Rasmus. All right, let's move on. I've mentioned it a couple of times. these specific firms, Vara Healthcare and Siasearch. Let's talk about Vara Healthcare first. So this is a machine learning news show, and I've deliberately brought you on at this time to fill us in on some breaking advancements in this field in radiology. So not only has the Merantix AI venture studio been making TechCrunch headlines as recently as a couple of months ago, but Vara Healthcare, this Merantix subsidiary of yours, a breast cancer screening platform, was making headlines just last week in early June 2020 when it raised 6.5 million euros, so about 7 million US dollars, in Series A venture capital. So let me frame the problem here. According to the World Health Organization, breast cancer is the most common type of cancer among women, with 2.1 million women being diagnosed each year. And early detection is critical here, where stage 1 patients see a really high survival rate. So, in cases where the breast cancer is caught early, survival rates are very high. But in stage 4, which is the most advanced cancer stage, if the cancer is caught in stage 4, survival chances are quite low, an unfortunate 15%. So, early detection is key, and the process of analyzing mammograms is time consuming and repetitive. So there's an opportunity here for automation where manual assessment isn't this kind of bottleneck on getting that early detection, right? So tell us a bit from your perspective about the state of radiology today and how solutions like Vera's are revolutionizing outcomes for patients.
Sure. Thanks. That was a great summary, John, of the state of this space. I think it's a very exciting space for machine learning and especially computer vision because you have a ton of data, and you have a task that is highly critical, as you mentioned, because if in the case of breast cancer, for example, the cancer is detected early, its survival rate is really high, but if you miss it, actually it can be very deadly. And so um, and it's also an area where doctors, because they are under a lot of stress, but also because um, it's actually cognitively a very difficult task to analyze these mammograms, that this makes actually it a very good application for machine learning because in the end, our algorithm, and with Vara, we basically built this breast cancer platform, which has been learning from millions of mammograms to basically detect which ones are cancerous and which
Mhm.
ones are not, and thereby basically help the doctors to spend much less time reading the exams and also help them to actually miss much less because right now around 1 in 5 cancers which could have been seen are missed, and so it's very bad, and obviously algorithms can do much better. We've been basically building this whole workflow solution which the doctors can use to um, prioritize their readings, which help them to look at the images and also can highlight what regions could be relevant, but then also help the doctors with the reporting. So it's not just an algorithm; it's actually an end-to-end workflow where we work right now with radiology centers in Germany, but also in quite a few other European countries. And so, yeah, last year we certified this medical product, and so now are very much in distribution mode, trying to get more and more centers on board, but also further improving the platform and improving the algorithms and all the support for the doctors around the solution.
Brilliant. I love it. So, one of the key things here is false negatives, right? So, physicians, if you're constantly seeing images, maybe it's been a while since you've had a coffee or had your lunch. We know in all kinds of industries, human fatigue leads to missing things. And so, with an algorithm like this, the algorithm can highlight, hey, there might be something here. Take a close look. And this draws the radiologist's attention to a particular part of an image, and then the radiologist can use their years of expertise and training to follow up, maybe do some extra scans or do a tissue autopsy. So this makes perfect sense to me, and it's brilliant how you've tied that algorithm idea into the broader workflow, which of course is critical to getting people on board and wanting to use your technology. Having, as you mentioned, having the right algorithm is 5% of it. I like that percentage. I think that's about right.
Yeah, and I think it's also a good example for like a company we would like to build with Merantix. So there's the algorithmic part, which is incredibly hard because it's really about making them robust and deal with all sorts of edge cases. But it's also about building partnerships with dozens of hospitals to share the data in a GDPR compliant way. It's about building workflows that doctors actually like using and actually helps them on the daily jobs. It's around certifying AI products as and working with regulation AI. So I think there's exactly
Right.
all these different parts we like to bring together, which ultimately only will create a positive impact. Because yeah, it's super easy these days to train an algorithm on some public available datasets. You can probably do it within a few hours. But getting this medical product out there, which
Mhm.
has obviously much larger impact, is totally different beast, but ultimately important. That's so that we can all benefit from this.
Right. We can all benefit from it in terms of a healthcare perspective, but also commercially, it makes a lot of sense to me because you build by dealing with all those aspects of it, certification and adoption, you're building a large defensive moat around the company as well. So that works out really well. In recent years, so I want to get into a bit of a, this might be controversial. I have no idea what you're going to say to this. But in recent years, with the advancements of convolutional neural networks like the AlexNet architecture that we talked about at the beginning of the program that made a big splash right before your PhD, two of the most prominent experts in machine learning made predictions that might send chills down physicians' spines. So, Jeff Hinton, we already mentioned him. He's the guy who ran the lab that created that AlexNet architecture that completely transformed the world of machine vision. I would say it definitely transformed the world of machine learning. It brought deep learning to so many people's awareness and it really transformed the world in many ways. So, this AlexNet technology was huge, and Jeff Hinton had been working on deep learning related research for decades. Him and Yoshua Bengio and Jan LeCun, they were jointly awarded last year the Turing Award, which is like the Nobel Prize. It's the equivalent of the Nobel Prize for computer science for their work on deep learning. So many people call Jeff Hinton the godfather of deep learning. And in 2016, he said, this is a quote, "It's quite obvious that we should stop training radiologists." And this is because the deep learning algorithms have become so powerful, so capable of detecting tumor types. And because it takes so long to train radiologists, he says, look, it's going to take 10, 12, 15 years to train a radiologist when they start medical school through to having this specialization. We should just stop doing that now. And then a year later, Andrew Ng, who is maybe the most famous machine learning practitioner of all, he founded Coursera and has countless papers and patents behind him. In November 2017, he said something similar. He said, radiologists should be worried about their jobs. So, do you have any thoughts on this yourself?
Yeah, I mean, I think it's I think I'm a big believer of the hybrid model. So at least for the next, I guess, decade, it's clear that for some types of radiological tasks, a machine is just better in terms of the precision and recall.
Mm-hmm.
Um, but still, ultimately, there might be some edge cases where the machine is not 100% sure what it really is. Where it's then great to have this hybrid model where you would then forward the image actually to the doctor and have them have the final judgment. So I think not using AI at all would be not the best for the patient, but probably directly switching to just AI is also a bit too extreme. So I think at least for the next couple of years, we will have a very much hybrid approach. And I mean, in the end, there's also a lot of other work the radiologists do, right? So
Exactly.
um, it's also all the interaction with the patients and then figuring out, okay, what are the next steps? It's running screening centers or like the radiology practices. So um, I think there's still a lot of other tasks which will not be automated by AI in the near future. So I think radiologists will be still around. At the same time, if I were to study or do a medical degree today and think about what I want to do for the next 40 years, I would maybe not focus on radiology. So I think if you look at it
Right.
on a 30, 40-year time horizon, um, I think radiology might work very differently than it works today. And so yeah, I'm very optimistic there that it's going to happen, but it takes some time. I mean, it's a very regulated industry for a good reason. I mean, it can be very critical, and so it will take a few years until there's really adoption at scale.
Yeah, this makes perfect sense to me. There's so much more to being a physician than being able to identify, some aberration in an image. And AI is not going to replace that anytime soon. And of course, AI is really, at least with the kinds of approaches we have today, like deep learning, it really is only effective in situations where the issue is similar to common issues in the training data set. So edge cases, things that are out of the ordinary, the machine learning algorithm probably won't notice at all. And so there's this huge gap so that, the machine vision algorithm can outperform the radiologist in situations where it's a well-defined tumor type in a common type of situation where there were lots of training examples, but it might be completely blind to unusual situations, which the unusual situations add up. So so from just being able to recognize aberrant tissues, I think that there's, like you say, there are algorithms that are outperforming in some situations, but still we need radiologists for that piece, and then for the broader piece, of course, we're going to need a radiologist for some time. I mean, even just for liability, right? I mean, the legal questions alone, like even if we had somehow some algorithm that could handle most aspects of a radiologist's job, which we are nowhere near, we would still have this big legal issue around liability. And so, even for that reason alone, I don't think radiologists will be out of work for, as you say, at least a decade or so.
Exactly.
Segueing now to another machine vision topic. This one is autonomous vehicles, so self-driving cars. Another Merantix portfolio company is a prominent and quickly growing player in this space. So this company is called Siasearch, and let me frame the issue here. So for decades, we've had motor vehicles with automatic transmissions. So, you didn't have to change gears manually. But other than that, car driving had been completely manual in terms of pressing the gas and the brake and turning the steering column. In the past few years, however, we first started to see cars that could parallel park themselves, and that seemed like a nice little novelty. And then Tesla, the world's best-selling electric car maker, which produced its millionth vehicle just in March 2020, released its autopilot feature, which 5 years ago started enabling folks to drive hands-free on the highway. Teslas, however, are limited to self-driving on the highway, and they may not be equipped with enough hardware, such as LiDAR, the laser-based type of sonar, to handle navigating in urban conditions. So Tesla's autopilot, great on highways, probably can't do cities. In 2016, however, a firm called Nutonomy launched the world's first self-driving taxi service in Singapore, and now several major corporations, ranging from tech giants like Google, with its Waymo subsidiary's little steering wheel-less vehicle, which has driven millions and millions of miles, to ride-hailing firms like Uber, to a slew of traditional automotive companies who would like to ensure they aren't left behind. We have tons of companies that are now launching completely self-driving vehicles. So in order to train all of these autonomous vehicles to be safe and reliable, we need tons of data. The vehicles all collect reams and reams and reams of data, about a terabyte of it every day. So this is enough to fill a typical modern laptop every single day, collected by every single modern pre-autonomous vehicle that's out there. So the millionth Tesla vehicle that was released in March, each of those million vehicles is out there recording a terabyte of data every day across a slew of cameras, lasers, and sonar sensors. And this then presents a problem. So these data are completely unlabeled. It's just a giant stream of information. And it's also often completely unstructured. So there could be tons of valuable data being collected, but the typical autonomous driving firm makes use of only 5%, so 1/20th of all of the data that's being collected. All right, so that frames our problem here. And Siasearch, this Merantix AI Venture Studio portfolio company, it sounds like you guys are working on the solution, right?
Thanks for the great problem description, Jon. Yeah, that very much is a perfect summary of the problem we're solving. So, how did we come up actually with this problem? So, It's also, again, I think, a great explanation for why a venture studio made sense. So we were actually working with some of the car manufacturers on various topics around machine learning, and we realized that like that a common problem that there was so much data coming in, and it was just laying in some buckets, sometimes in the cloud, sometimes on prem. And firstly, they didn't really know well what to keep and what to throw away. But also, then even when it was about improving the algorithms or even testing the algorithms in their automated driving features, there was no like neat way to access the data. And I mean, this was in cases where there was just a few dozen terabytes. Sorry. And now imagine once your fleet, as you mentioned, for Tesla goes up in the millions. I mean, you drown in petabytes of data, and you need to really prioritize and understand this data. And so
Mhm.
we've built with Siasearch a platform where you basically throw in all the raw data without any labels. I mean, it could just be from your cameras, it could be from lidars, but also other sensors, also map data, data about the car, and so then what Siasearch does is basically analyzing all this data, um, trying to also infer context, like what's really happening in the scene. Like, is this like a busy street? Is it not a busy street? Are there any pedestrians doing something? Are there any cars around? What kind of street is it? What's the weather condition? So it adds a
Wow.
ton of metadata, actually hundreds of things. That's one part to the product. And
Mhm.
then the other part is it makes this all searchable. So you can very easily say, hey, give me all the data where, I don't know, like a pedestrian was crossing very close to the car, or where, for example, you've had a cut-in on some highway. Give me like a thousands of these scenes, and then basically our querying engine pulls out this data very quickly, and then you can use it for your use case. And so we believe this is very important, first for using this data, but then also to reduce storage, because in the end you don't want to store hundreds of petabytes or exabytes of data, because like they're right now just using 5%, and they might still only use 5% in the future, but it's important to use the right 5%, because all the data about like empty highway drives or so, they're not so relevant. I mean,
Right.
an algorithm learns pretty quickly that how to drive on a highway, and so
Mhm.
that is data maybe where you don't want to store that much about. But if there's some super interesting critical situation interacting with pedestrians, you probably want to store all these sequences. And so the software also helps you to prioritize that. And so you basically just put it on top of your cloud environment, whether it's one of the big cloud providers or also some on-premise cloud, and then it helps making sense of that data.
Nice. I, again, like so many of the business ideas you've mentioned on today's show, I absolutely love it. And this was the context that you initially came up on our podcast last week, because we were talking about companies that exist out there to add structure and labels, metadata, like you mentioned, to images. There is a huge amount of opportunity in the last few years, I think, for companies to be doing this kind of thing. And it sounds like you guys have really found a great niche here. From what I understand, there's a lot of different car companies that are working with your technology. Maybe you can't mention them specifically, but I think I'm right about that, right?
Yeah, exactly. And it's interesting for anyone in the stack. So for the large OEM brands, the suppliers, people who produce sensors, the autonomous driving companies, basically everybody in the whole stack of automated mobility. So also it could also be companies producing robots in the context of logistics, even drones. I mean, we haven't done stuff in that space yet, but I think you could even expand that to other use cases where basically you have mobile devices producing a ton of data.
Yeah, that makes perfect sense to me. Did you know Alex Flint, who was also doing his PhD when I was at Oxford?
Yeah, his name rings a bell, actually. Yeah.
Yeah, he was in Oxford Entrepreneurs. I can't remember if you guys overlapped, if you were on the committee at the same time. He has started a few years ago a VC backed company in San Francisco, which specifically worked on autonomous driving for delivery. So, kind of like this drone idea that you just mentioned. We've seen things like Amazon mentioning that they would have technologies like this where you have this four-wheel device that rides around on the sidewalk and can make, last mile deliveries. And his company thought that this might be a relatively simple problem that would be easier than, say, self driving cars. But they realized over time that it was actually exactly as complicated as making a self driving car, because there's pedestrians on the sidewalk. And so they ended up being acquired by General Motors. So General Motors has a big autonomous driving division, and that ended up buying up Alex's company. So he's off working on similar kinds of problems as well. So interesting that's going on. All right. Well, to wrap things up here, fill us in on your vision, Rasmus, for the Merantix AI Venture Studio or your career. You've had an amazing journey so far. What's next?
Yeah, I mean, I think the biggest thing on our agenda is now um, building the next batch of companies. So I think you mentioned that earlier. We just before Christmas, and we announced it in January. We raised another 25 million euros, which we will basically use to build around 8 new companies in the next 4 years. So right now, it's
Wow.
really all about identifying those topics, assembling those teams, and also figuring out what kind of companies we will build. So that's one big part. The other part is kind of um, building even more synergies between our existing and new companies, and growing this Merantix ecosystem, because I really believe that having a lot of companies, AI companies, next to each other in close collaboration in a very trusted environment will just help them all to be more successful. And so we want to institutionalize this a bit more. And um, then lastly, Merantix is kind of my 95 or 98% job. The other couple of percent I actually spent with the German Association of AI Companies, which I co-founded 2 years ago,
Huh.
where we basically
Wow.
are around 250 companies now, and at kind of the intersection of, I guess, startups and small medium businesses that use AI or are AI first, and um, working closely basically with the German but also European government, and being in on exchange to see what needs to change in terms of regulation, or if there is now money that is being invested in the space of AI from the government side, what are efficient ways to allocate it. So kind of building the bridge between the policy side and the startup AI world is another thing I spent some time on. I'm very excited because I believe we're still only the beginning. Like, you could say that the early
Of course.
AI hype is a bit over now, but I think now the next 10, 15, 20 years will be super exciting when it's about actually seeing all these things in application in the real world, like in radiology, like autonomous driving and all these things. And so, driving this forward, yeah, very excited about it.
That is awesome. I had no idea you were doing that. And it's such a great compliment to the other work that you're doing to, at one end, be growing startups quite pragmatically and saying, okay, where are there business opportunities for us to be applying specific breakthroughs in machine learning? And then on the other end, you're saying, okay, how are we going to make sure that society is ready for these changes and that politicians are working with us to come up with appropriate regulations? This is so important because we need to make sure that the progress that we're making in AI isn't all of a sudden cut short by some societal or political backlash. And I think that there is definitely a risk of things like that happening. I think that sometimes big tech companies can be using people's data in a way that makes users uncomfortable. And then so we end up with regulations like GDPR, which I think are great. I think that it's important to be looking after citizens' data, and citizens should probably have more control over their data. But we also want to make sure that simultaneously there's a balance that means that we're not putting a chokehold on machine learning advances. So brilliant. Finally, Rasmus, as should be clear to listeners at this point in the program, you've attained a tremendous amount of success in your career for anyone. Forget for someone as young as you, only a few years out of your PhD. Do you have one particularly valuable nugget of advice for listeners who'd like to scale machine learning applications commercially themselves?
So one thing I'm very excited about is self-service solutions in the context of machine learning.
Mm.
So um, obviously there are like applications of vertical AI solutions, like what we do with Vara, where we basically solve one specific problem with machine learning very well. But you also end up having a lot of problems out there which are very specific to the company. So it might be some small manufacturing business that maybe wants to use deep learning for some visual quality control, and it's something which is so specific to what they do that there will probably never be a product out there. But at the same time, what's out there for on the open source side is still, yeah, you can download some open source code, but then you still need to host it somewhere. You need to make sure it's robust. You need to deploy it. And so I think there's a big opportunity in the next couple of years to build kind of self-service products where small companies, but potentially also large companies, can basically customize some machine learning workflow, whether it's computer vision or natural language processing. And so I think that will be a very exciting space to start a company in the next couple of years.
That sounds great. Thank you for that, Rasmus. So it's been a really interesting program. We've been able to cover so many different news topics through discussion with you directly, which is a kind of format we haven't had on the program before, but I think works really well. So we were able to talk about scaling AI businesses. We were able to talk about applications to radiology specifically, and we were able to talk about autonomous driving news as well. So that covers our content in today's A4N program. Rasmus, is there anything coming up soon that you'd like our audience members to know about, or would you like to provide them with, details for reaching out to you, a Twitter handle, or anything like that?
Yeah, feel free to reach out to me on LinkedIn, Rasmus Rothe, or my Twitter handle is Rasmus Rothe also. So yeah, always happy to start conversations around machine learning, around applications, around investment in this space. There's something very exciting we are planning right now in Berlin, which will basically broaden the Merantix ecosystem. I can't tell you much about it yet, but we'll probably announce it in July. So
Cool.
follow us, and then you'll see what's going to happen.
Nice. Very exciting, Rasmus. I can't wait to find out what that is. Listener, thank you very much for your time and attention today. We greatly appreciate it. Please consider liking, subscribing, or following the A4N podcast. It's available on Apple Podcasts, Spotify, Google Podcasts, and YouTube. And yes, feel free to reach out to me as well. Like Rasmus, I'm on LinkedIn, and in terms of social media, as with many people in this space, that is my most active social media channel. Of course, all of our handles, any links that we mentioned in today's program, I will be including in the blog post related to this podcast episode on my website, jonkrohn.com. I do have on my website, there's an email newsletter on the homepage that I recommend that you sign up for. That is the best way to stay in touch. Any new podcast episodes, lectures, free videos that I make. I have tons of free content that I create and I share via that newsletter. So I do recommend that. I am also on Twitter at Jon Krohn Learns. Thank you very much to our producer, Songbin Lee, for production and editing. And of course, our guest, Rasmus. Thank you so much for being on the program. We will catch you again here soon.
Thanks, John and Songbin. It was really fun.